Welcome to the second part video for emulsion dosage form. In this video, we are going to explore calculations and apply the theory that we have learned. Let's calculate. So before we can calculate, we have to recall the theory. Let's look at what we learned in the previous video. The oil must not be below 20% of the product volume. If it does, the emulsion will be unstable. To meet the 20% requirement, you can use a blend oil, for example, arachis oil, sesame, cottonseed, and maize oil, to maintain the stability of the formulation. There's a ratio. Ratios are proportions to which the primary emulsion is guided. The oil represents the first point in the ratio, then the water, and then the gum. That order you have to be able to recall, and the formulations with the examples you have to remember on your own. These are not given in tests or exams or any quizzes that you may get. The fixed oil ratio is 4:2:1. Mineral oil is 3:2:1, volatile oil 2:2:1, and oleoresin, male fern extract 1:2:1. And the order is oil, water, gum. Remember, these are proportions. The oil is milliliter, water is milliliter, but the gum, acacia, is a powder, and so that answer should be in grams. Preservative, benzoic acid preserves any liquid at 0.1%, which means 0.1 gram for each 100 milliliter of preparation. Syrup we use at 10 to 20%. This means 10 milliliters to 20 milliliters if it's a 100 ml preparation. Flavors can range at 0.2% if it's artificial, and natural flavors 1 to 2%. Let's look at our first calculation. The first calculation, the stability requirement is maintained. No blend oil is necessary. Let's look. Cod liver oil, 30 milliliters, and water to 100 milliliter. Remember, percentage is out of 100. And so without calculating, this is a 30% volume in volume oil requirement. And so the stability is fine. No blend oil is necessary. So we need to then go and calculate the primary emulsion. Remember, you cannot make an emulsion by just throwing water and oil together. They are not miscible. And so we have to first make the primary emulsion. What is the primary? The gum acacia is used as a coating to coat the globules of oil. So the oil will be added to a mortar and pestle. The pestle will be mixed, and using to mix, we call it trituration. The oil will be broken down by the pestle, and as we do that, we are coating it with the gum, and the gum keeps the globule in its discrete individual globule state. Now, this cod liver oil is a fixed oil, so the ratio for the primary emulsion is 4:2:1, which means oil, water, gum. Remember now that the oil is 30 milliliter, and so that will be designated 4 parts. This is a table just to remind you. Let's do some calculation. So if the oil is 30 milliliter, that represents 4 parts automatically. So 30 represents 4 parts, so X represents 1 part. And so that is the calculation for the gum, because remember, the gum in the ratio and proportion is 1 part. The water represents 2 parts. So 30 milliliter is to 4 parts. So how much is to 2 parts? 15 milliliter. And as you can see, it's half. The water is half the oil, right? And the gum is quarter of the oil. So you can look at these things and see if you have the correct answer. So the primary emulsion has its own new formula. Whenever you are doing calculations for emulsion, 2 new formulas are given. One for the primary emulsion, because you have to make the primary emulsion before you can make the finished product. So the new formula for the primary emulsion is cod liver oil 30 milliliters, water 15 milliliters, and acacia is a powder, so that will be 7.5 grams. Remember, we use the designated method. dry gum, or wet gum method to make your primary emulsion before any other ingredient can come in contact with the formulation if you want an emulsion that remains stable. Now, what if we modify the formulation and say to you, add a preservative because it's a water formulation and it can spoil, and the patient will have it at home for a while? We need a preservative. We're going to look at a scenario where we add benzoic acid. Recall the theory, 0.1% is necessary. Now, the stock available is benzoic acid BP. Benzoic acid BP is actually an internationally recognized name. It is the name, just like where you have Mercedes-Benz for a car, or Honda or Hyundai. Benzoic acid BP is actually the name of a stock that is a 5% concentration. And so please review how to do stock calculation for this part. So 0.1 gram of benzoic acid is needed to preserve 100 milliliter of medicine. No further calculation is required because coincidentally, we're being asked to send 100 milliliter. So we then need to work out the stock. For the stock of 5%, it means 5 grams of benzoic acid is contained in every 100 milliliters of the stock solution. So therefore, the 0.1 gram that we need will be found in a 2 ml aliquot. The syrup, recall the theory, 10 to 20% of the volume, and so we're going to choose 10 milliliters for this 100 ml product. You can use up to 20, you can even use 15% because it's a range. Now, for the benzoic acid, we could have used C1V1 equals C2V2. Let's see how that applies. C1V1 is the side of the equation that deals with the stock. The stock is at 5%. We don't know how much milliliters we're going to use, but the C2V2 is the dilution, which is the product. We know we want a 0.1% and the product is 100 milliliter. So when you set up your calculation, transpose to make the unknown the subject of the math, then we end up with a 2 ml aliquot similar to the previous slide using ratio and proportion. Students are free to use ratio and proportion to calculate the preservative, or you can use C1V1, which is a quicker method. This is what the product's new formula looks like. Cod liver oil is 30 milliliter, acacia is 7.5 gram, the benzoic acid we solved to say it's 2 milliliters, and the strawberry syrup we're using 10 ml, and the water. Please bear in mind that the water for the primary emulsion is not repeated. So when we read the product new formula, you should not be seeing water appearing twice. No, there is a new formula for the primary where the water for the primary will appear, and then there's a new formula for the product where the water for the primary emulsion is not repeated. Please bear that in mind. That brings us to sample calculation number 2, where the stability requirement is not met and we have to add a bland oil. Using the same example, I've modified it. So let's read this prescription. Cod liver oil, 2.5 milliliter per TBSP, which means tablespoon. So each 15 milliliter should have 2.5 ml of cod liver oil when the patient drinks a tablespoon. Benzoic acid, QS, strawberry syrup, QS, and water. And remember, there's a hidden ingredient, which is acacia, because you cannot make an emulsion without a stabilizer or an emulsifying agent. So when you do your concentration check, we can do it 2 ways. The 2.5 milliliter per tablespoon that the patient is to drink, we get 16.7%. Or when we do the calculation, we find out that it's 10 ml of cod liver oil in the 60 ml product, we get the same 16.7 ml. And there is the calculation. To meet the stability requirement, 20%. 20% of 60 milliliters should be 12 ml. And our product is landing at 10 milliliters. So there's a deficit of 2 milliliter, and we are going to use a bland oil, arachis oil, to fill the gap. Here is the interpretation. 2.5 milliliters per tablespoon means It's a way of expressing concentration, by the way. It means that for each tablespoon, it's carrying 2.5 milliliters of cod liver oil. So therefore, we need 10 milliliters for the 60 ml product. And that is below the stability requirement because the stability requirement says we need 12 ml. So 2 ml needs to come from somewhere, and we are going to use arachis oil as that 2 ml of bland oil. So now you need to go and figure out the primary emulsion, the oil water gum, 4:2:1. Also for this scenario, I'm giving you benzoic acid 3% instead of the 5% in the previous example, and strawberry syrup. So of course you need to be able to recall the theory. If you do not recall the theory, you cannot do the calculation. So in this context, the oil is 12 milliliters. So again, remember, whatever the oil is, it represents the first part of the ratio table. So 4 parts is now 12 milliliters for this question. So therefore, the water would be half of that, which is 6 milliliter. And the gum will be a quarter of that, which is 3 grams. Remember, the gum is a powder, and so it's 3 grams based on the calculation. So the primary emulsion for this question will be cod liver oil, 10 ml, arachis oil, 2 ml, water, 6 milliliters, and acacia, 3 grams. So there it is. You have your new formula for your primary. So your responsibility now is to go and do the calculation for the 3% benzoic acid solution. You can use ratio and proportion or CSVS. Replay the video and look at how we did it earlier. And you can choose if you want your syrup to be 10 to 20%. So this takes us to your take-home activity. You are going to go to Moodle platform. We are going to set up a Dropbox for you to do your assignment and post it. It's your self-practice. We will audit to see if you're doing the activity, and you'll do this after watching the 2 videos. Your first instructional example is calciferol oil, 0.15 milliliters per teaspoon. You are going to send 75 milliliters, and I've given you a master formula to somewhat guide the architecture of this medication. You are going to use cottonseed oil as your bland oil if your stability requirement is not maintained. All other ingredients as per listed in the master formula. The second example is going to allow you to do a mineral oil where the ratio is different from a fixed oil. And so it's 5 milliliters per 15 ml. Remember to do your stability check. It's a part of your calculation to see if it meets the 20% criteria. I'm giving you benzoic acid 2% for this example, cherry syrup, and you're going to work out your acacia. Remember that you are to have 2 new formulas for emulsion. One for the primary, because you must make the primary before you can add any other ingredient to the emulsion. If you do not calculate the primary or make a primary, then the medication, the oil, will separate from the water, because remember, the acacia is the gum being used to stabilize the oil in a globule form, so it's nicely scattered throughout the water. That takes us to the end of this video, and I hope that it was very beneficial for you. Please go and do the activity on your Moodle platform. Thank you.